in lots of developers' offers, there are significant transmission reinforcements that developers' schemes are sitting behind. So Hinkley Connection project's 59 kilometres. That's fairly substantial. Some of the other reinforcements are over 100, maybe 200 kilometres long and involving multiple substations. That's why developers need to just look at the Hinkley Connection project. This is what it looks like, and what's the impact on my project that is sitting behind a similar, if not more extensive, transmission reinforcement project.
Hello and welcome to the Connectology podcast, where Road Night Taylor's influential team of connection specialists and their expert guests help you to better understand distribution and transmission network connections. This episode is part of Pete Aston's look at the Hinkley Connection project, for which he was responsible for the design elements in his time at WPD. The project is a new 59-kilometre transmission circuit running through Somerset. And looking at the Hinkley Connection project will help developers understand the scale of transmission reinforcement more broadly, and will give them insight into what it means for connections affected by new proposed transmission works. This episode is an introduction to Pete Aston's look at the Hinkley Connection project. I'm Hugh Taylor, and Pete, my first question for you. So we know that the project is a 59-kilometre transmission circuit. Could you just fill me in with a few more details?
Yeah, thanks, Hugh. It's a new 400 kV circuit that's required, running from more or less the Bridgewater area all the way up to sort of Bristol Docks area. So right through lots of Somerset, North Somerset, into sort of parts of West Bristol area. It's required, sort of the name gives it away, for the Hinkley C new nuclear power station that's currently being built. I think the actual technical requirement was more of a network stability requirement, bit of a techie thing, as opposed to absolute capacity on the transmission system. But network stability, you don't want a 1.8 gigawatt turbine tripping off and getting damaged. So yes, it's being put in for network stability. So in terms of actually how it's being built, it's being constructed using new T-pylons, which sort of look like wind turbine columns, then with a T-piece on top. So quite an innovative design, not being used anywhere else in the world. So that's quite exciting, very interesting, seeing those pop up all over the place. In terms of some of the engineering side of things, it's predominantly used a 132 kV corridor. So there's been existing 132 kV lines that run from Bridgewater up to Seabank substation, as it is in sort of Bristol Docks area. That 132 kV line has come down in places and is going to come down in other places to make way for the new 400 kV circuit. It's a really substantial piece of work. Obviously, the local distribution network needs that 132 kV circuit. It wasn't just there doing nothing. And so because that 132 circuit's been taken down, in place of it, there's a new grid supply point being built. That's going to be connected into the new 400 kV line, so new 400 to 132 kV transformers. And then that's going to patch into the remaining 132 kV network. So that's called Sanford Substation. And then lots of work's happening up at Seabank and Bridgewater and at Hinkley Point itself. Lots of new substations and so on. So that's the sort of the general flavour of what's going on.
Brilliant, thanks. And just your insight, other than the fact that it's local to you, but could you just very briefly outline what your role was at WPD, now NGED, in the Hinkley project? Yeah,
sure. So I joined WPD, as was NGED now, back in 2007 as a planner, network engineer. My patch happened to be the sort of North Somerset patch, looking at the 132 and 33 kV networks in that area. And it was 2008 that National Grid first started talking to us as a company, and me very heavily involved as the planner of that area, about the need for a new 400 kV circuit. So my works were for many years looking at the design elements of this. So what happens when you remove a 132 kV circuit from the network? Actually, how do you plug the gap? If you need a new grid supply point, how do you link that in? And then moving on from some of those initial design stages, obviously National Grid had to do a lot of optioneering about different routes. That wasn't obviously my responsibility. That's what National Grid were doing. But part of that was engaging with National Grid with not just the design elements of work, but public consultation. So I went to a number of public consultation meetings and sort of drop-in sessions where the public could just walk in, talk to the National Grid guys who were doing the work, talk to me as the distribution representative, a whole load of things around that, sort of from the design and moving into the public consultation type space, starting to talk with both National Grid and Western Power delivery teams about, well, how we're actually going to implement this, because it's not just like a normal reinforcement work that might happen over a couple of years. This is a program of works that's happening over sort of 5-6 years. So you're not just looking at the end stage as to say, oh, this is what it's going to look like when we finish. You've actually got to plan to keep the lights on for everyone in Somerset and North Somerset throughout that whole process, to keep the network secure and rebuild it at the same time. So that was really interesting to see that then move into the delivery phase. It's being constructed now as we speak.
Great, thank you. And with that in mind, the fact that this is clearly a huge project and that there are technical impacts and social impacts as well, could you just let our audience know why you thought that this case study is actually relevant and why we're making a podcast about it?
Yeah, it's really relevant for 2 reasons. Large-scale new transmission reinforcements do not happen that regularly. So the Hinkley Connection project is the most recent large-scale transmission reinforcement project. The one that would have happened before that would have been many years before. So it's not something that happens very regularly. I think just from that point of view, it's really interesting just to look at what's going on. Not least that the Hinkley Connection project's using innovative pylon designs. It's also got a significant section of underground cable in the middle of it as well. So there's some real interesting engineering challenges. But I think the more important reason that developers will be interested in this is that in lots of developers' offers, there are significant transmission reinforcements that are now planned that developers' schemes are sitting behind. And some of these transmission reinforcements make the Hinkley Connection project look small. So Hinkley Connection project's 59 kilometres. That's fairly substantial. Some of the other reinforcements are, over 100, maybe 200 kilometres long and involving multiple substations. So some of the other reinforcements planned are even more significant than this. And therefore, that's why developers need to just look at the Hinkley Connection project as sort of a case study, an example to see this is what it looks like. And what's the impact on my project that is sitting behind a similar, if not more extensive, transmission reinforcement project?
Cool. So that makes sense because there are so many of these really big transmission schemes or schemes impacted by transmission reinforcement works. And some of the connection timeframes, I think I heard of 2037 yesterday. And actually, that doesn't really make any sense, but this is actually now going to give us this series will give us some context through which developers and investors who are acquiring these projects can a lens through which they can look at these works.
Yeah, absolutely. 2037, that's only 14 years away from now. And one of the things that needs to be brought out as part of this series is timescales, because timescales is a massive thing. It's taken 15 years from when I first talked to National Grid in 2008 about this project to now when the works are substantially complete but not yet finished. And no doubt National Grid were thinking about it before they talked to me about it. So, from a National Grid point of view, this has taken even longer. By the time it's finished, it will have been a 16, 17-year project.
And that's amazing just to hear you say it's only 14 years. I think for those of us within the industry, our clients, these connection time frames, when they were coming out at 2028, there was a sense that was a very long way away. But actually, your experience of Hinkley, it isn't at all.
That's right. And I think that there are some, factors that have delayed the Hinkley Connection project. There's no doubt about it, because it was so closely linked with the actual Hinkley C scheme itself, which went through a number of delays. There were periods where progress could have been made earlier on the actual transmission reinforcement works. That there's probably a few years delay within there, but that's not unusual. Delays happen for all sorts of reasons. So even with a sort of a good project program, delays are going to happen for reasons that we just can't foresee now. So 2037 for some of these long projects doesn't seem unrealistic at all. And in fact, some might argue, maybe I might argue, it seems optimistic.
Blimey, that's not what we want to hear. If you're liking this podcast so far, you may want to pop over to the Connectology page on Road Night Taylor's website and sign up to the Connectology newsletter for much more know-how, insight and thought leadership in electricity network connections. The link to this is in the description. Don't miss out on any of the articles, explainers, videos, webinars and podcasts that Road Night Taylor's connectologists share to give you an edge and help you overcome your grid frustrations. So what are some of the highlights that you hope to bring out of this series? And I know that one of them is the connection timescales and the long timescales associated, but what else is there?
I think there's a cost implication here, and that's not necessarily cost implication for developers, and I think there's more of a wider sort of GB cost issue here that needs thinking about by lots of people, National Grid, Ofgem, government. Is just that these transmission reinforcements are very expensive. I think when the Hinkley project was awarded funding by Ofgem, it was awarded funding for something like 650 million. I think National Grid had asked for over 700 million. I haven't seen a figure as to how much this actually cost them. Projects generally don't happen for less money than they were predicted to happen. So I'm pretty sure the costs will have gone up beyond that. So, we're talking very high costs here. And as a country, we just need to think about that and maybe step back and think, are these transmission reinforcements the best way of solving the problem of getting towards net zero? And let's not forget that this is what this is all about. This is trying to move the country towards net zero by installing all these renewable technologies all over the place. So there's a big picture question there. I think there's another one on resource available to do all this work. So National Grid, has got a limited resource. National Grid uses contractors to do a lot of its work. They've got limited resource. So when there's hundreds of kilometres of reconductoring works to do, and then hundreds of kilometres of new circuit build to do, that takes a massive burden on resource right the way across the industry. These projects can't all happen concurrently. So which ones get prioritised? Which developers win in terms of sitting behind projects that actually get pushed forward faster than others? So I think that's a really interesting one. There are a few of the big things.
And I know as well, because you live locally, you've been very interested, and because you were involved in some of the kind of the local community engagement meetings, that the social impact is something that you're quite tuned into. And perhaps you could just explain for the audience why you chose your first interview of the podcast series, which we got in the can, so that's going to be the next one, was with Dr. Liam Fox MP.
So, yeah, Dr. Liam Fox is the MP for North Somerset, so that's the constituency where I live, and it's one of the constituencies that's most impacted by the Hinkley project. So I think there's 3 or 4 sort of MP constituency areas that are impacted by the Hinkley project, the new transmission line. And Dr. Liam Fox MP was very, very heavily engaged in those initial consultation processes. He was hosting debates between National Grid and members of the public and so on. He was very engaged in Parliament, talking around the impacts of these things. So when the public are impacted, they go and speak to their MP. And then if the MPs are being spoken to, they'll bring it up in Parliament, and then, laws get passed, which then affects the ability of transmission companies on the National Grid to then do what they want to do. So the whole thing is one big web of interconnection. So I think, yes, politicians aren't directly related to connections, but the laws they pass very, very closely affect all of this transmission work. So that's why I wanted to speak to him, because he's got a lot of insight into how the process works in Parliament, and there are going to be lots of constituency areas, lots of MPs affected by transmission reinforcement. across other parts of the country. So it was really interesting to get his insight into that side of things.
Yeah, and I've listened to it already. It was fascinating, I thought. And he has an amazing voice. So everyone's got that to listen to. It was like silk. Just to wrap up, really, because this is only meant to be a short one. Everyone's got busy lives. There was one more thing, and that is the pressure on the network companies. And I think you did briefly mention the fact that there is a resource issue within National Grid, but actually this is going to impact all the network companies because they're all fighting over the same resource.
Yeah, so I think there's a resource issue. So in terms of just the contractors that are being used, there's only a few contractors that will build transmission lines. As you know, maybe a few more contractors who build 132 kV lines, but it's the same sort of pool of people. I think the other resource thing is the internal resource. So the design team resource, for example. So there aren't many DNOs where there are groups of designers who have dealt with large-scale transmission reinforcements that end up taking down 132 kV lines and needing new GSPs. Because it doesn't happen very often, the DNOs haven't got the exposure to that. So they've got the people within their teams who are more than capable of doing it, but they need time to grow the teams, to build that experience, to build those relationships with National Grid. It was good fun, but it was challenging to build those relationships between WPD and National Grid. What sort of meeting schedules do you have? Who needs to meet? Who needs to talk together? And all that sort of stuff. And that takes a long time to actually work out, just those logistics, let alone agreeing on design principles and so on. So that's the sort of impact. It takes a lot of people out of normal everyday life, which then, of course, the DNOs aren't just sitting there twiddling their thumbs.
Normal everyday life for a DNO at the moment, for a system planner within a DNO is a complete nightmare. And
so
our thoughts
just
with them.
Add this on top, and it just becomes a situation where the DNOs probably then need more engineering resource to internally to then be able to deliver this sort of thing.
Yeah, and this actually just brings us on to, so we got one of the, I think it's a webinar, that we're actually recording today is about third-party works, which I think has been a bit of a curveball for an awful lot of people, particularly who are acquiring projects. And I guess because I don't understand third-party works, but was WPD's involvement essentially third-party works around a transmission connection?
It was to start with, because so you've got EDF who were building Hinkley C. They triggered the need for the new transmission circuit, which then triggered the need for WPD to take down their 132 line and do lots of amendments to their own network. So that was just one big third-party works project. It transpired that the Hinkley Connection project eventually got classed as some sort of strategic reinforcement project, and then was, I think, somewhat disconnected from the Hinkley C build out itself. So I think it sort of became not a third-party works thing at some point in the process.
But I guess there is that impact of transmission connections on the distribution network, those third-party works, which we're going to cover in a podcast. But hopefully this in itself will just kind of raise awareness of that, which is important within the industry.
A much bigger third-party works impact than the transmission company saying, I'm taking down your 132 kV line for 50 kilometres. It just becomes a massive, massive issue. And it just becomes a collaborative, working together process. And I really enjoyed it. It was great fun. Challenging, but who gets to work on big transmission reinforcement projects like that? In your career.
Cool.
Doesn't happen very often. So it was a privilege actually to be involved and good fun as well.
Excellent. And clearly because I know when you first came to me with the idea of this podcast series, you're really looking forward to it, and I'm really looking forward to it too. So thank you very much.
Pleasure.
Thank you for listening to this episode of the Connectology podcast. If you found it helpful, please share it with any of your colleagues or connections you think may be interested. And please do subscribe at Apple Podcasts, Google Podcasts, Spotify, or wherever you get your content. You can find out more about our services at roadnighttaylor.co.uk, link in the description, where you can also sign up to our free Connectology newsletter for more news and thought leadership in network connections. If, during this podcast, you found yourself wondering what it would be like to have a Road Knight Taylor connectologist in your life, Please do email laura@roadnighttailor.co.uk to find out how their game-changing skills and insight can change the game for you too.